Year 12 mathematicians, we all know how important differentiation is as part of A-level maths. So we're going to have a look at a couple of questions today that have a really important difference that you need to make sure you understand if you're going to be successful. So first question, we're going to find the gradient of the curve with an equation that's been given to us at a point where x equals 2. So it looks like a fairly standard question. We're going to do our normal routines for this. So gradient function for a curve, we're going to do our differentiation. So dy dx, differentiate following our normal rules. It's multiplied by the power, take one off, so we get 9x squared times by 2 gets us minus 12x, and then plus 7 tagged on the end. So we have our gradient function, and we've been given a point where we would like to know the gradient. So we're going to use x equals 2 and substitute it in to our gradient function. So when x equals 2, we know that dy by dx is going to equal 9 times 2 squared minus 12 times 2 plus 7, and we're just going to work out that value. So 2 squared gets us 4 times 9 is 36, minus 24 gets us 12, plus 7, we get 19. That is our gradient. In some questions, we might then go on to find the gradient or the equation of the tangent at that point, but for now, we're just going to leave it there and have our gradient of 19. Fine, fairly straightforward, used to doing that. So we're going to have a look at another one, question 2, where there's a really important difference we need to make sure we understand. So the line with equation y equals minus a quarter x plus c, this is a straight line, is normal to the curve with equation, and then we've got another quadratic this time. We would like to find the value of c. So again, we have to make the connection we're talking about gradients because we have this normal here. So if you remember, a normal is perpendicular, so 90 degrees to a tangent. Okay, so the tangent gradient, the normal will be 90 degrees, the perpendicular to that. So we're still talking about gradients, so we're still going to differentiate. So we're going to take dy by dx equals 6x minus 8. So there's our gradient function. Question now is, what do we do with it? So if this line is normal to the curve, we know that this has a gradient of minus a quarter. So what would the gradient of the tangent be? It's time for some straight line geometry. So we know if we know the gradient here and we want a perpendicular line, we take the negative reciprocal to find that the gradient then would be, flip it, let's change the sign, positive 4. So this is our tangent gradient because this was our normal gradient, right? So we've done our negative reciprocal, found out the gradient needs to be 4. So this time, and here is the key difference you need to make sure you are clear on, we know what we want the gradient to be. This is our gradient function, so we equate them. So we take 6x minus 8 and we equate it to 4 because we don't know what x is, but we can find out by equating our gradient function to the gradient we want of 4. So we go and solve this, so we add 8 on, so we get 6x equals 12, so x equals 2. So that means at the point where x is 2, we get a gradient of 4, which means our y equals minus a quarter x plus c is perpendicular at that point, or normal to the curve. Okay, fine, so we've got that far. We want to find out what the value of c is. So this equation of the line here has to intersect our curve at that point where that's the gradient. So we need to find out where that point of intersection is. So we know that x equals 2, okay? So we can take that and substitute it into our curve equation to find out what y would be. So we can say y equals 3 times 2 squared minus 8 times 2 plus 7. Go through and work that out. So we get 2 squared is 4 times by 3, gets us 12, minus 16, gets us minus 4, plus 7, we get 3. So the point where the line is normal to the curve is at the point 2, 3. Don't know why I wrote a 7 there. Edit that. So we get 2 there, 3 there, so that's the point. So we can now use that with our y equals minus a quarter x plus c to find out what that missing value of c actually is. So if we take the point 2, 3, and we put 3 equals minus a quarter times by x, which was 2, okay, because that's what we found over here, plus c, and we're just going to find out what that would be. So 3 equals minus a quarter times 2 gets us minus a half. Add that half on, we get 7 over 2, and that is our value of c that makes y equals minus a quarter x plus c a normal to that quadratic. So our big key difference there is we're either substituting a value we know in, so we knew the value of x, so we subbed it in to find a gradient, or we know the gradient that we want to have, and we equate it to find a value of x. Really, really important. Two different styles of question, both using differentiation. You've got to be clear that you know the difference. Let me know in the comments how you got on with that. Subscribe for more maths content from us.